Hello guys, this is a video where I might want to respond a bit on I was watching a video by Digital Foundry about a lot of tech news, and at some point they talk about the Mortal Kombat 2 homebrew port by Zone. I have been talking with Zone. We have been discussing about his work, and I have been helping a bit with some code suggestions, and I think he read my tutorials or I haven't finished the tutorial, but some experimental code I have been releasing in the community that shows some basic things about how do you do 2D sprites and other stuff with 3DO. And I have been paying attention to that, and it's really impressive what Sean has been doing. Before Mortal Kombat 2, there was a Tetris game for 3DO, and he really was pushing it for attention to detail and trying to get everything at 60 frame. If it goes 30 frames, no, we must get 60, and I like that one. I have the theory that if you have the will to optimize things, if you don't just finish some code, something, and say, okay, the 3DO is bad, that's the best it can do, take it, I don't care. If it's slow, it's slow. No, if you push yourself and maybe you really love the machine, you can do really cool things with the 3DO. And I think it's underutilized sometimes and underappreciated. Everybody thinks, oh, it's an full motion video porn machine. It's not okay. It's doing the quad raster. It's not doing real 3D, and it's okay. It's forward rendering of bitmap to arbitrary quad areas, stretching bitmap. But you can utilize this to render texture areas fast, and you have to do a lot of CPU work for the 3D transformation. Although there is a hardware matrix, but then there are more stuff in between that have to be done on the CPU. But if you utilize them, which I'll show later by my own experiments, you can do a lot. You can do a lot of cool stuff. If you look at a retro platform like, oh, those platforms are slow, I'm just gonna try something random, and if it's slower, the platform must be bad. Then you're gonna come out like, oh, 3DO is so slow, so this, so that. And on Digital Foundry video, the Digital Foundry video, I was watching it. And they are discussing of the Mortal Kombat 2 ported to 3D, and at some point, oh yeah, okay, I was looking on my YouTube video. Okay, there is a new Digital Foundry video where they were discussing various tech news and this port, and some of the presenters opened it with the idea that, I always knew that 3DO is not good at 2D. And I was like, what? Because, okay, the fact is, it's not a powerhouse. Maybe the Jaguar can push more big 2D bitmaps, but it's still quite good or quite decent if you know what you're doing. Like, it's not horrible. It's not like you're gonna do your best and your game is gonna be 10 frames per second or something. You can easily, if you have the will and understand the machine, you can easily, much easier than 3D. 3DO is struggling on 3D. If you see most of the 3D games on 3DO, they struggle to get a good frame rate. Some of them do somewhat, maybe 20-25 frames. But a lot of them are 10-15 frames. But most of the 2D games I've seen are really good. Maybe they are 30 frames and not 60 frames, I don't know. But they are smooth. And I know it from personal experience. And the video was saying maybe I should start playing also. I don't know which version I have. Maybe I don't have the latest version. So the video was saying, oh, I always knew that 3DO is not good at 2D. So when I saw Mortal Kombat running so smoothly with big sprites and big background, I was amazed. I was like, this is impossible. This cannot be on 3DO. This is impossible. I don't know how it looks. I'm recording from OBS and maybe it doesn't look very smooth. It's really a 60 frame. Now it doesn't seem here. Now I don't remember the movement. Because I'm also talking. So, but the presenter's reaction was, I thought it was a miracle. I would not expect. How do you play with? Oh, okay, I found it. Anyway, I'm gonna lose now because I don't pay attention. So, what I want to say. Oh, okay. So the presenter was amazed from this one. He thought I would never see something like this so fast on the 3D because the 3D sucks. But my experience is when I've seen that, I say, okay, cool job, Sean, the creator of this. Great attention to detail, great frame rate. But I wasn't thinking I was seeing the import. I was thinking, yeah, it's very possible if someone works to do that. It's not like the 3D. If I saw a 3D first person game running at even 30 frame rates, let alone 60, I will be like, how? But if I see a 2D game with it basically has a background, it has few layers like the chains here and the sprites and the floor is doing some parallax line per line, as far as I know. It has few foreground layers. I could be like, yeah, this is possible on 3DO if someone really takes the machine seriously. I couldn't think that it's the impossible thing because I have an understanding of how much the 3DO works. I have an understanding and how 3D are not so fast, so bad. They can easily reach over 60 frames per second if you pay attention to your assets, if you minimize texture reach. You don't even need to do some godlike programming. It's more of asset management and knowing. I don't know the fatality. It's more like that. Because I have been working in a lot of demo scene and tech demo code and some game dev now with the 3DO for years, and I know a lot of the ins and outs of the machine, and I know it's really good for 2D. If you don't know what you're doing, you might get under 60. If you know, you can easily get over. You might have to reduce some of your assets to reduce texture. And when I saw a game like Mortal Kombat, I see cool, but I believe it would be hard to tweak the assets to get the frame rate and tweak a lot of other things to not drop under 60. but it's not something impossible because people underestimate what the 3DO can do. I also believe even in 3D, if it really puts to its own 3D, that I expect to see something really impressive. That I would think like, how did they do that? And maybe I'll just show you some of my experiments so that you understand where about is the power of the 3DO. Maybe I should show you that. It's not the best, but it's not how Digital Foundry described, like, oh, I thought 3DO is really bad with today. It really suffered. Because it's the 3D games where it suffers. It's the 3D games where the PlayStation 1 is a winner. And even the Sega Saturn. Now, on the 2D, it's doing good. Maybe Jaguar has more throughput through memory for 2D. What is he doing? Why is he grabbing his penis? But you will see you can easily, even with homebrew programming, without some godlike code, without low level assembly, you can easily do some really good stuff with the cell renderer. And on the CPU, even in C, you can, especially for 2D games like that, you can easily get it to do things fast. For example, I will try maybe the parallax. I have 3 examples here so far. This is an old. I found my new code and something happens and it crashes, but the old one is enough. The backgrounds layers is important. Now, I wanna say now I'm using an FZ10 console. It's a European PAL, so if I V-sync on this one, I'm gonna hit 50. If the examples cannot reach 50 frames, it's gonna drop to 25. But I also have an option to disable V-sync so that you can see it's gonna be flickering when I do so, so that you can see the actual output. So let's see. I have to remember the keys now. Maybe disable the background sport. There is an extra. So there is this capability of 3DO where you can have a static background but it cannot move. That it's throwing it through DMA very fast. But here, even if I disable the VSync, it's gonna show 50 frames per second. Now if I disable the sport and I disable the VSync, it's doing nothing, it's just clearing the screen. That's another mode where you can clear the screen very fast with DMA. And so we have really fast clearing. You don't need to make a big code that has the black color. But if you want to clear the screen with the DMA Sport S-Sport feature of 3DO, it has to be a static background. It cannot move. And it's gonna be this. Now, in 3DO, if you enable this background, it's gonna lock the VSync. You cannot disable the VSync when the background is on. So now, if I start putting things, one background, even with transparency, these are 16-bit, big 16-bit background. Without transparency, with transparency, the other background, much better. It's 50 frames. It is VSync. Now it jumped between 14 and. Now if I put both of them, you see it drops at 25. But if I disable VSync, because of the sport background, you still see 25. Now if I disable the sport from the back and disable the VSync, okay, you get 27. If I disable the blending, you get 33. Maybe disable for the other one. Okay, for both. I have two different buttons. Now, no screen. These are big. These are actually 640 by 480 scrolling. And I'm getting 43 frames per second. It's not a 2D powerhouse, yeah. But such graphics are big for 3DO. And they're not gonna go well. Now, if I remove one of them, you see I'm getting, without VSync, I'm getting 80 frames. So that's the limit. Or I can disable and put the other one. If I VSync, it's gonna lock at 50. So a full screen 320 by 240. It's 640 by 480, but I efficiently cut a sub window that is 320 by 240. There is an efficient way of doing this, and I'm doing it. I'm not rendering the outside. I'm rendering exactly the window on the cell renderer. Without the sync, that's the limit. A full 320 by 240 covering the screen is gonna get 80 frames, which is, you say, okay, it's over 60, 50 or 60. But it's barely there, because if you wanted to make two full layers, which I'm gonna do, you're immediately are gonna drop under. You're at 43 frames per second. And definitely if you decided to blend them, you're gonna get to 30. Now if I enable VSync, it's going to 25. And I can throw the sport in the background. Now this background is for free. And I can blend it, and I still get 50. But now I cannot disable the VSync, because if the sport background is on, in the hardware specification, VSync will be enabled for the DMA transfer of a stable background to clear on the previous frame. It will enable it. But if I disable the sport, technically this is blending now with the black background. If I disable the blending, you're gonna get at 80. And now I can enable both of them. I'm blending everything now. The frame rate says 17. Now I'm rendering everything. I had a third background, this one. This one is also, I try to make a lower. It has this few color because it's either a lower depth color or a compressed. It could be 4 bits per pixel. I don't remember. But now you see one, but it's all of them together. All of them together remove the scene. So if you want to throw big backgrounds, it's not bad. 16-bit per pixel. You can go with 8-bit per pixel. The smaller the size of the text to read, the faster it will be. So when one screen when this one was 80, I wonder if this one is 80. Oh yeah, this one is much faster, 190. Because it's not 16-bit per pixel. It might be 4 bits per pixel. It might be compressed. So the text to read is much less. That shows if you select carefully your bitmap, if you don't just throw the most high quality 16-bit color and so on, but You have graphics like in Street Fighter, for example, that yeah, you could do this with 8-bit per pixel. Or you could do regions of the background. Maybe there is a region of the backgrounds with 16-bit per pixel, 8-bit per pixel, 4-bit per pixel. You could break a background in. Okay, I need to stop this. So what I want to say is there is potential, but you are not gonna get it by throwing the biggest, highest bit depth backgrounds without care. You need to tweak your assets. You need to say, okay, I have an asset that maybe I can reduce the colors a bit or do some compressions or just display a part of it, especially if you do parallax. For example, here I have another test. It is the parallax test where I don't have full screen images that are filling the whole screen, but I have images that have gaps, that have a lot of transparent pixels, that especially if you compress this image as well, the 3DO, the cell renderer will skip a lot of pixels at once. And here I have three big layers. They are a bit, some of them have ugly pixels. I just got some pictures and converted them from the internet. I'm at 50 frames. Now, if I disable, okay, I cannot disable the VSync. The background image, the sky with the sun is a sport. I have to disable it. And now I can disable the VSync. So I have 3 parallax or even 4 parallax, 2 gates, and I get, depending on where they are, I get from 60 something to 70 to 80 something. And this can be improved. And I think I can throw, let me see. I can throw this. And I'm getting a bit over 50. Also it's barely 16, depending on where it is. Let's see. Ah, yeah. I can blend it, but of course when I blend it, it's going at 25. And without VSync, it's going at 40. And if I put the sun, yeah, surely it needs tweaking. And you see, I can have big layers of multiple graphics, a background, the 3DO scrolling with blending, with real-time blending, and still get the 25 frames. Sure, it would be nice if I got the 50. And 25, if you remove sport and VSync, this goes over 30, this goes 40, 41, 39, depending on what is on the screen. When those cages, those gray doors go away, it varies because they are outside and I'm not rendering them. That would look at 30 frames per second. But because if you put the sport background, you're gonna have this thing whether you like it or not. And then you can do tests. You can disable that and you can start and say, okay, I'm gonna, which one is this? Okay, I'm gonna remove the layers. Clank, clank. This one, 146, 168 frames. Full screen scrolling of this thing. Let me see. How did I? Okay, just the gates. 300, 200. You see, you can bleed really good graphics. Just the grass. 166. The grass and that. Everything together. Just those two. 90, 100, depending. It is the way I scroll. I mean, with the 3DO and everything, all these layers, sometimes 50, sometimes 25. This thing is enabled. If I blend it, it's gonna drop. And that's it. You see how good 3DO is with 2D with big layers. It's there, but you have to tweak it if you want to make sure. But it's a lot of layers already. It's not that I'm trying to do few things, and I could even think of ways to make it more efficient if I wanted. So maybe I'm going to run a few things shortly. There was another demo. It wasn't parallax. Sprites. I was inspired by an Atari Jaguar demo where you had the Jaguar, a picture of a Jaguar, and it was broken in 4x4 blocks from the image of sprites. They were also 16 bits per pixel. I'm also exactly the same. 1920. And I tried to recreate it, and there was a bit of optimization of the cell rendering. I noticed that there are some certain flags that which I could manipulate this flag. It was a bit esoteric. I could manipulate this flag to skip certain values from the data. Even if it's 16 bits per pixel without a palette, if there was a flag that made it load a palette, it will still, for every little sprite, it will steal the extra 64 bytes. Even if I have set it to null, maybe not. So there are things you can. I couldn't get it over. Now I will disable vsync. This is 50 frames because of PAL. I disable vsync. This is easily going at 79, 81, which tells you, yeah, I can hit over the one vertical refresh from 50 to 80 or from 60. Well enough. But in my initial test, I was under, and then I discovered a lot of things about doing more efficient cell rendering, especially with small sprites like this. And also initially, initially I had this bitmap, this image in a big bitmap, and there is a cell function on the hardware that you can take a sub window cell from a big image that is I don't know 256 by 200. What was that? I don't remember the dimensions. You could select a sub region of a bitmap, but I realized this was slower, and instead of I read the full picture and create separate, more linear bitmaps. Every 4x4 part is a different bitmap data. I've done a lot, and also on the CPU, because I have to move it. How do I move it? I use the CPU to rotate and move, and it's not what you would expect. It's not a matrix that is multiplied by the point for rotation. It's something more optimized and simple. So I had to do some CPU work to be able to get the 80 something frames. But here we are. I can do things with a lot of sprites. on 3DO, similar to the Atari Jaguar demo. So 3DO doesn't seem like a machine that you will do 2D and you will be like, oh my god, this is horrible, I cannot do anything. It seems something that it's really interesting and nice if you just go and naively write code and you don't investigate, both on CPU and the cell render. If you think if you throw the first thing there, for example, I'm gonna say something. I'm gonna say that it's not that there are few rules you need to follow, and some experimentation. You have to test yourself what makes performance better. If you want to make drawing a lot of cells on 3DO, like my previous example, fast, the naive, first of all, here in a 3DO dev, you go to developer documentations. I usually go here. There's a lot of. These are some old data. It's a bit. These are the important things. It can be a bit chaotic. Now, there is also the lib3do function if you want to use some extra stuff. But you might not need it. But if you understand the cell structure, this is a structure. It's like 60. Is it? Yeah, 60 bytes, 15 words that will describe a quad, a bitmap that you will render as a quad, a stretch quad. And you would upload the source pointer to the bitmap. You might have the palette lookup table. These things will be manipulated to position, zoom, rotate, and even stretch to create any arbitrary quad. It's not so hard. I have explained. This might help you with blending and shading and so on. It gets a bit complicated. Those are something that describe the bitmap width, height, and length in words and some other stuff. Those are some other flags. And this is an important one. Next pointer. You can have one CCB stack, one cell, one bitmap linked, and link it to the next one, and then link it to the next one, link it to the eventually that can be the last one will have null, or you can also mark the flag for the last one last. Like so you can make sequence of cells and give the draw call to the first one. And this is the draw cells that it takes. That bitmap item has to do something with the screen setup, but it gives a cell. And the usually rookie mistake someone can make, although it might not matter much if you have very few sprites on the screen, is to call draw cells for every individual cell. You have 1000 polygons, make 1000 call to draw cell. That's gonna be really slow, and you could do that and get awful performance. Oh my god, 3DO is horrible. I can't even draw 100 polygons without dropping under 50 frames per second. Because you have to link them, you have to understand a bit the thing. And then there is also the map cell. That's a helper function. You can write better ones. You can write better ones in assembly. Although it's not bad, but there are different versions. Depending if you have power of 2 bitmap or not. But you can give a structure with the 4 points, the cell, and this is gonna. So you can give any arbitrary points. It's gonna do some fixed point arithmetic and vector arithmetic to create those values, which are some sets of vectors to really describe the position and stretch your quad points to produce any polygon area you want, even some twisted polygons that are like curved surfaces or some weird stuff. And you could start making experiments with that with few polygons, like make a 3D cube and so on. Now the 3D, okay, the 3D, you have to do the 3D on your own on the CPU. But in the final step where you know what you have projected your points, you can render stuff. So the link cell is something that will link two cells together, but it really just points this in the struct, the next pointer to the next cell. You can do it your own. You might not need it. This is on different library, the lib3d or lib, and you might not need it. You might need this is some auxiliary library really, which you can avoid linking to gain a bit on memory. And here is a very short one that explains some things. The other thing is, because of forward rendering, now that doesn't go there. If you have a big picture and you read a lot of data, like my big 16-bit screens, that's a lot of texture reads. And if you could reduce that size, so you could be rendering a polygon that is far, far away in the distance. It could be some pixels, very few pixels here, but the original image could be big, and it could be still very, very slow because it's gonna read all the pixels because of forward rendering. Huge cells draw slowly. There are some good. There are simple. You need few rules to make things somewhat faster, and then experiment from there. Link your cells and tweak your assets as much as you can afford to not reduce the quality so much to be lighter on the size of the data, on the texture data that are read. You can do some texture loading if you render bitmaps far away. You can do all kinds of stuff. So here, I have been doing a lot of things. With sprites. Maybe the pact. Although, I might have finished what I wanted to say. Maybe this one. Now this one is still an experiment that I was hoping to get over 50 all the time, but it doesn't. Let's see. Now this is suffering, except I have too many layers, too many stuff. You see on the upper right I have unpacked. This means that those textures are not compressed. And I'm gonna make them packed. Okay, I'm getting the 25. Now, the background is still the sport image. Let's see if I can remove it. Maybe not. I cannot remove the background. Yeah, I cannot remove it. We're not gonna get over 50. Now, if I remove that, we're getting the 50. Now, it happens that these two layers, one is 4 bits per pixel, 16 color. It's the rotating whirlwind thing behind. I have generated, I have packed it. I have written procedural generated code that generates it and understood how the cell packing works and wrote my own packer and unpacker. And if I disable, now it's unpacked. These are big images, bigger than the whole screen. And it means now that at the places where there are transparent pixel, if it's unpacked, I'm gonna read every pixel. Not me, the cell renderer is gonna read every pixel and discard. Oh, that's a transparent pixel. Go to the next. A lot of text to read. But if it's packed, you're gaining a lot for sprites, backgrounds that have big areas that are transparent, for example, because linearly in the bitmap, it says the next 50 pixels are transparent, and it uses 2 bytes. 1 byte might have the size, and there are the 2 last bits is the functional. There are 2 bits, 6 bits for the following pixel, so it can be from 1 pixel to 64, and 2 bits to say, is the next following pixel transparent, the same color repeating. Here there is the same color repeating also in some. Now this thing is rotating, but it's in original unrotated form. It's packed in some original unrotated form. The rotation is the rendering of the cell, the rotation of the vectors for the quadrasterizer. And the foreground is 16 bit per pixel, but there are a lot of horizontal lines, and these are packed really well. So if I put, okay, this on its own packed, this has big areas that are inside packed, and outside in the edges there are individual pixels. Unpacked, I still get 50. Oh, sometimes it drops from 50 to 25. Packed, it does much better. It struggles, all of this struggle. But there is a lot of big sprites, a lot of layers, a background. And I think if I press, I see information in the lower left, 725.3. This is the percentage of packing, if I remember. Like the cross probably, it's 7% from its original unpacked size. It's something that is like 640 by 480 for BPP, and it seems to be packed really well. I think it's that 25 must be the second. The stars are 8 BPP, 8 bit per pixel, and they are packed at 25%. And the background, the layer background, this ugly colored thing, 16 BPP, but very well packed because it's horizontal lines that goes from the left to the right. And you see again roughly how packed and unpacked. I make them unpacked and it suffers, it goes to, and that's good VSync. I don't know without VSync. I cannot disable the sport background. And maybe I should show you the 3D engine I'm going. My impression is always that, okay, you need some effort to do something with 2D graphics and not go from 50 or 60 to 25 or 30 FPS. Don't go into 2 VBLs. But it's even harder with 3D graphics, and you can see it in the demo. In my opinion, the 2D games are doing nicely. Maybe some of them are 30 frames and not 60. Or in PAL it would be 25, but because they have to lock to some, maybe not necessary. It's nice to lock in well with the vertical refresh. So if you are in a PAL and you cannot reach 50, you're dropping to 25. And maybe it's better to not have screen tearing and so on. But all games I've seen, most of the 2D games, they look fine. They look smooth enough. And there is the issue with the 3D modes being interlace and not progressive scan. So you have all the different scan lines. So someone would argue, yeah, it might not make much difference of 60 to 30. Also, in my experience, from the user programmer perspective, when I vsync, I get a 50 or 60 frames depending on the hardware. If I'm well above that, if I really hit above the one screen refresh, I'm gonna get that number. So I never forced it. Oh, because of interlace, I have to go to 2 VBLs or something, or do something else. And a lot of games seem to me like Super Street Fighter and the new Mortal Kombat, because they try to tweak the background and the sprite assets to reduce texture reads. They do all kinds of optimization. Probably not call draw cell for every individual sprite, unless there are very few sprites that it wasn't so important. So you can easily do, if you want, if you have the will and you don't do things naively, just throw super high color depth assets there. You can easily do some good stuff, but you still have to be careful. Now the 3D is a different thing. The 3D is, it's pretty tough. You need to do a lot of work on the CPU. There is a hardware matrix multiplication, 3 by 3 and 4 by 4. There is hardware matrix multiplication of the matrix by a list of vectors. There is matrix by matrix. I don't know if the matrix by matrix is in the hardware, but I have used the 3 by 3 by a list of vectors, a big list of vectors, and it's faster than doing it on a fixed point integer on the CPU. It's like 2 or 2.5 times faster, depending on how you do it on the CPU. Maybe I could have done it more optimized on the CPU, but I think I've done it optimized enough to test. So anyway, so you needed to do a lot of stuff. You just have this matrix and this quad rasterizer at the end at the image space after you projected on the CPU. The projection has to happen on the GPU. Division is low. You can use reciprocal multiplication with a big lookup table, which is what I've done. And you need to do visibility, some kind of clipping, and a lot of other stuff in the CPU. So it's a bit tough. And that's why most 3D games on 3DO, besides having to work with a lot of individual polygons and do a lot of processing there, mapping the 4 points to the 3 vectors of the cell on the CPU, they struggle. And if you can get 15, 20, 25 frames on your 3D game, you are doing really well. Maybe you get 10, 15. You start to struggle there. And I have seen games on the 3DO in 3D that are even under that. They are like 6, 8, 9 frames. So anyway, I'm gonna run the latest version. I was trying to do some loading also, so that you know where you have seen where the 3DO with 2D is, and you're gonna see with 3D. This is still a work in progress. Now there's supposed to be some audio, but I don't hear anything. But okay, I'm just going to explore. So this is my engine. Do I have, okay, I have up and down. Yeah, I can look up and down. It's really like it's a real engine, but you know, these big walls are split into a lot of separate quads, so that I repeat the texture. So you might see a big area, a big flat wall, but this is split in a lot of quads, like 1, 2, 3, 4, 5, 5 by 5. So you have a lot of quads there, and you see there's a difference in the shading. The cell renderer can shade. It's like a flat shading. It's not Guru shading. It's a regular shading per quad. You can darken and brighten a quad the same way you can blend. These particles are blended. And you see the frame rate on the right. You see those particles. Now here the room is small and I'm getting 20, 19. But of course here it gets more involved. I still manage. I think I should be able to optimize. And you might see a lot of 3DO games, even simple, not even getting this frame rate. But also you see some that are really impressive, like Total Eclipse and Starfighter 3000. Now this one is doing some kind of texture loading. So the far away textures, it might not be visible. See the wall there? It's gonna get really ugly. Now the wall there is a 4x4. I move, it pops. I can improve the load. I have made it very short. Now it helps a bit. It helps a bit with the cell rendering struggling with too many texture reads. If the far away textures are too small, why read the 32 by 32 texture? These ones are 32 by 32. They are 4 bits per pixel, 16 color sheets, palletized. Every one of them has its own palette. Now it's flickering because I have disabled the VSync. And here is a big map now. This is complex. This has a lot. This has a big hole here. And it really, I'm still really struggling. And it's not just the accelerator, it's the CPU processing that I still have to improve. When you look up, there are so many far away. Okay, I get 10 FPS. Maybe I was getting 9 FPS from what I remember. Because of the accelerator. On emulator, on Phoenix emulator, I was getting 12. Because it tries to emulate the cell bottlenecks, but the emulator is a bit better than the actual hardware. And after doing this loading, it went from 9 to 10 from what I remember here. But this loading means that I did extra CPU processing, which I tried to optimize a bit. I rewrote some things in assembly recently. And I tried to minimize, to get the average Z as I'm sorting. I'm sorting all these polygons. I have a good sorter. And it's not ON square, it's not even ON log n. It's like a ON in complexity. Some kind of Z bucket sorted lists that I have developed for other stuff. So you see, you can get good frame rate if you design things that are small rooms. The stars are software rendered, by the way. I'm rendering in the video RAM of the 3DO that is a bit non-linear and different than the cell, and this is the most optimal thing. You could make these stars to be individual cell quads of pixel size 1, but I found out this is too much hassle to prepare them, and this is a bit slower. I found that efficient software rendering, really pixel plotting of those ones, the way I did, I found it was the most optimal. I'm doing partially some. Oh, I'm gonna die here. Maybe I should stop. I'm doing a lot of CPU work, but I'm trying to minimize. I have some partial visibility where I'm not trying to render the whole map. If some corridor is hidden by another corridor, I'm not even sending. I have split the geometry in different meshes. So there is an effort and I can improve. But so far it's like that. And you kind of see from my experiments where I really try to optimize some things. I'm really obsessed with performance and in this hardware and a lot of other platforms. You see that's how much roughly I have reached several layers of 2D stuff, compressed, uncompressed, 16 bits per pixel, 8 bits, 4 bits, all kinds of experiments, 1920 micro sprites. You see, I can roughly get it there. If I do a real 2D game, I can, and I don't reach 60, 50 or 60 frames, I can maybe tweak it and fight it to get that as much as possible. But then even 30 would be okay. If some of the things we are watching are 30, and you see on 3D, the 3DO can do, if you tweak it, it can do some cool stuff. I believe I could optimize this engine a bit more. Although I need to start writing some things, writing some gameplay, adding billboard sprites and small meshes, adding something. But okay.